Have you ever wondered, when you're looking at a job, what if I did this a different way? For instance, this job looks like a typical milling and turning. Just let you look at it here a little bit. And that's the way it was processed for quite some time. But with a little help, we were able to optimize how the job gets processed. We'd like to show you how in this video. The first thing we did was to lay out the job the way we thought we could do it on a singular vertical machining center. So we do side 1, side 2, and there's a little hole had to get put in up here. So we did our layouts here and took our STL files from the CAD and brought them into Run MyVirtual Machine. Well, the first thing we have to do is determine what size machine we need to manufacture this part. In this case, the Track VMC 7SI. We're going to look at it, and for clarity, I'm just going to turn this enclosure off. And what I've done in here is I've got the 3 parts here from the CAD, and I've got devices and the setup all complete here. So if I go to Machine, Setup, and just double click on that, I can look now and see that fits on the table quite nicely. So this machine will do for this particular component. But that's not the real question. The real question is it more profitable to use a mill and a lathe on this job, utilizing 2 machines, or is it more profitable to use a singular machine on the job? Let's find out. Okay, we've got the machine all programmed with our shop mill conversational programming. Could have just as easily been done in the CAD CAM, but for this purpose we'll use the conversational. And let's just run the part. Do a little in-process inspecting. It's called Cut, Measure, Cut. It will adjust the offsets for you automatically. Bring your parts into size. Now, the one thing you can't afford down on the shop floor is to have bad programs of geometry, and whoa, here we've just had a crash, another crash, another crash, and another crash. When it's convenient for you, what you can do is you can come up here to collisions. And I can see here that this is this collision here. So I've got 4 collisions here. And it looks like they're all in the same plane, which should make it easier. I can come in and find out what collided with what. But clearly you can see what's happening and where you need to go in the program to fix this issue. Now, you may have been off doing something else. Those were pretty minor crashes, but they're still crashes and need to be addressed. Or we drill and center drill and tap that tiny hole on the third part. We're getting our cycle time up here. Now we're running quite a bit faster, about 350% faster in our verification process than the real-time machining of the part. Nevertheless, the times here are accurate. They're not sped up like we are with it. We're just doing it quickly in the verification to get it over. A little more in-process gauging. We can get our results up here. I'm just going to freeze that for a second. Yeah, see, we're off a little bit here, so we can make the adjustments now to the program automatically and have it come back in, remachine the part. Just doing a little engraving here. And that's it. So our run time is 17 minutes and 46 seconds. When we ran this job, what we did is we took the program from here, put it in the VMC7 on our shop floor, cut the part, and the actual run time was 17 minutes and 15 seconds. So it was a little bit quicker at the machine than here. But certainly we're within a margin that if you're bidding a job, you want to figure out the best way to do the job, or you're bidding the job for the first time, however it might be, you can rely on the machine time from Run MyVirtual Machine. And you can't say that about any other digital twin they call themselves. This is a digital twin, an exact digital twin, because we're using the same PLC in our offline software that we're using at the machine. So the Excel, decel rates, all of that type of thing, they're identical to the machine. Tool change time, everything is the same.